All right, so you've had a chance to take a look at the Star Relationship Explorer activity on your own. You did some graphing, took a look at some data, and tried to interpret what that data was supposed to mean. So what I wanted to do is spend a little bit of time going through it and making sure that you understand what you need to understand. If you have questions after watching this video, make sure you either send me those questions or stop by a Zoom, or we can talk about it in class as well. The first thing that I just wanted to discuss were some of these key words. One of them being nebula. Okay, so a nebula is this object in space made up of gas, particularly hydrogen and helium, as we discussed before. Those two elements are the building blocks of stars. And then there's also dust in this nebula. So you can kind of think of a nebula as a cloud, right? Clouds outside are made of gas and dust, but the composition is different and the size is just extremely different as well. Nebula are humongous, okay? And they are humongous because they eventually turn into stars, okay? So that is a nebula. Another word that came up a lot is this idea of luminosity. There's a lot of different ways to measure brightness of a star. We have absolute and apparent magnitude, which you'll learn about a little bit later, and then we have something called luminosity. And luminosity is more of a measure of how much energy stars are producing. And in order to get a luminosity, you need the radius of the star and then the temperature of the star. And both of those we can measure based on the light and observations from those stars. So luminosity extremely important for this activity. And then the other thing that showed up a little bit is this idea of a main sequence star. And a main sequence star is just a star, a specific portion of a star's life cycle, which again, we'll talk about more after we get through these explore activities. So from here, you guys took all of this data from stars, including our sun, the luminosity and temperature, and you were supposed to graph that information. So your graph should have turned out a little bit like this one. Okay, don't get all worried if your x's are in slightly different places than mine, but you know, this is what you were supposed to get. And then from there, you were supposed to take a look at different relationships or patterns that you saw, and then try to group these based on those patterns or those clumps of stars. And then compare it to an HR diagram. And what you created here is an HR diagram. And so HR diagram is completely based on the temperature of a star and the luminosity of a star. And it can tell us a little bit about the stars themselves, in particular where a star is in its life cycle. I talked about this main sequence being a stage in the star's life cycle. And hopefully you saw that most of the stars that you graphed ended up on that main sequence. So a pattern or a noticing that you should have gathered from that observation is that most stars that we see, that we can observe and collect data from in our sky with telescopes, are on the main sequence. Okay, fewer stars are in the giant or supergiant or white dwarf stage, and you'll learn that not all stars will go to these different categories. Okay, so you know, like I said, this is your HR diagram. The HR diagram that you were to compare to looked like this. Made it a little bit more clear where some of those stars are, and then also kind of gave you an idea of proportion of size, right? Okay, so again, kind of creating this line down the middle of the HR diagram are the main sequence stars. Just off of the main sequence, we've got giants. Okay, varying different colors. That was another thing that you should have noticed on yours compared to this one, is that stars are different colors, ranging from red to dark blue. We also have these big red supergiants in the upper right hand corner. We have blue supergiants, and then we have these white dwarfs kind of down underneath the main sequence. Okay, so that was one step in this process, right? You went through and color coded, right? Number 5 was comparing, and then you were labeling the stars. Okay. Now, if your labels weren't in the right spot, feel free to change them. I would change them so that you can use this to help you understand the HR diagram and these relationships. So please make sure you correct. All right. Looking in at some of these questions, we'll start out with question number 7, which is what is the main relationship between the temperature and star luminosity, or that energy brightness? Okay, and the answer here is usually, okay, especially when we're taking a look at those main sequence stars, that pattern, the hotter the star, the more energy it's going to release, and the brighter it's going to be. Okay, so if we take a look at our main sequence, we can see low temperature down here, okay, also related to a low luminosity over here. Okay, and then as we move up this main sequence line, we can see in the upper left-hand corner of the HR diagram, we have very hot stars, right, 40,000 or Kelvin or higher, and a high luminosity. Okay, that is the general pattern. However, there are some exceptions to that pattern, right? We have these white dwarfs down here, okay, and they're dwarfs because they're small, okay, and if we're dealing with luminosity based on the radius, that's going to play a role in where these things show up on the HR diagram. These stars are extremely hot, okay, but because they're small, and because of what's happening with these white dwarfs, they're not producing a large amount of energy, okay, which is going to bring them down here on the HR diagram. The giants, on the other hand, okay, or supergiants, are called that for a reason. They are extremely large, which is going to make sure their radius is really, really big, okay, which is going to give them a large luminosity, okay, and you'll learn this because of what red supergiants and blue supergiants are doing. They're producing an extremely large amount of energy, and that's what luminosity is all about. However, the surface, okay, the thing about this is that the temperature here, this is based on the surface temperature, okay, not the internal temperature, okay. The surface of these supergiants is cooler, okay, so the big relationship that you're supposed to take away from this is what we see in the HR diagram, right? Cooler temperature, surface temperature stars have a lower luminosity, whereas higher temperature stars have a higher luminosity. Okay, that was the big takeaway. All right. Question number 8, it says, what relationship can you find between star temperature and color? And then were you able to relate this to objects that we see burning on Earth? Okay. And again, taking a look at our colors here and our temperatures, the red stars, okay, have a colder temperature, surface temperature, compared to, yellow stars, which have, a warmer temperature, compared to dark blue stars, which have an extremely high surface temperature. And hopefully, so the relationship is the cooler the color, the warmer it is, which is confusing to us, right? Typically when we think of temperature, we think warm colors like red and orange are hot, right? Because that's, with all the visuals that we see, that's what we're supposed to remember. A flame is red, so it should be hot. Okay, but the warmer the temperature, the cooler the star is, which hopefully, if you related this correctly, when you take a look at like a campfire even, or, let's say a Bunsen burner, or if you have a gas fireplace, when you take a look at the very source of the flame, whether campfire or any of those other examples, when you get closer and closer to the source of that flame, the color of that flame is quite a bit cooler. It's, blues, all right, especially if you have a gas fireplace. That is blue, and it is extremely hot. Okay, and as you move away from the source, especially if we're taking a look at a campfire, that's when we start to see those yellows and those oranges and those reds. So the further away from the source of the flame, the cooler it gets. Okay, so hopefully you gathered that from your experiences. Okay. Question number 9, how does the sun compare with other stars that are part of the main sequence? Okay, so when we take a look at all those main sequence stars, our sun is right here, kind of smack dab in the middle. Nothing overly exciting about it. It's not super warm, not super cold. Okay, so, and then in terms of size, the size here isn't going to be anything to be excited about either. Okay. Spectral class of our sun is G. Again, taking a look at where it falls on the temperature scale and then going up to the scale up here, the spectral class. Okay, that's G. And then the last question is about a spectral class B star, what color, and then what temperature. So it should be a lighter blue, and then, you know, kind of in the range here from 12,000 to 30,000 Kelvin. Okay, so a lot of information we can gather from these HR diagrams. Okay, so if you have questions, let me know. Send me a Schoology message, show up to a Zoom, ask it during class. Watch this again if you need to. All right, here we go.